Okay, finally for these sets of videos, let me have a look at question 2 in part B. So here we are given a very short Java file and we're given a protocol state diagram, and our task is to modify the Java so that it's completely consistent with the protocol state diagram. So how are we going to set about this? I'm going to modify it here in Eclipse. You could use anything you wanted. So we are inclined to look first at the states, but actually that's probably not the most productive thing to do. We can probably expect that the existence of these two states, on and off, is going to correspond to the two values of the Boolean is on. Let's take that as a working hypothesis. But actually the easiest thing to look at really is the operation names, because the names of the operations, which are the names of the messages the object of this class is supposed to understand, should correspond to the events that occur on the transitions. So what have we got in the diagram that's supposed to be definitive? We've got a new bulb and a condition that we'll come back to. We've got an on, an off, and a tick. Well, what have we got here? Well, we've got tick, okay, and we've got new bulb. We haven't got an on or an off. We've got a switch on and a switch off. There's our first inconsistency. Okay, so it's as simple as we're going to change the name of those operations, and I'm going to comment because we were asked to comment briefly to say what we fixed. Change name from switch on, and I'm going to do the same with switch off. Okay, so far so good. Now it's going to get slightly harder. Where shall we go? Let's start at the beginning with the start state. So we've got, when our object is created, we come into this high level state. That doesn't help us very much because we want to know which of these we arrive in. So to understand that, we have to understand the semantics of this history state. So this says, if we've never been in this large state before, then go where it points, namely to off. So when the object is first created, it should be created in state off, according to this. But if we arrive in this large state via a transition, in this case this is the only transition we can do that by, then we should go to wherever we were before. So if we take this new bulb transition, then we should go to on if we were on and off if we were off. That's slightly weird by comparison with the real world, but it is what this UML shows. So let's see what the Java says. Now the Java says, well, I see. We have a default value for this private Boolean, and the default value we've got is true. In other words, we are defaulting to being on. Now that's not what the diagram says. The diagram says we should default to being off because of where the history state is pointing to. So there's our next error. Let's default that to false. Okay. Doing well here. Now what else is there to do? Let's check the transitions next. So still on the assumption that is on corresponds to being in state on and is off corresponds to being in state off, and that's fine. And remember, we don't need a name correspondence there because this is an abstraction we're making. We're supposed to say, in the obvious way, we're supposed to have the on method takes us from off to on unless we're already on, in which case it does nothing, and the off message takes us from on to off unless we're already off, in which case it does nothing. So let's check these things. Okay, so on says if not is on equals true. Okay, and if. Okay, so if we're off, then turn us on. If we are on, then turn us off. So that's correct. Good. Now, what other transitions do we have here? Well, we've got a tick transition here, but only on the on state. That's slightly curious, because what we've got here is a tick message that can be received in any state. We've got no kind of condition on that. Okay, so we found another bug. This should have a condition on it that says we only do the result of this message if we're actually in the on state. So let's put that in. Should be if is on. Remember, we've got this slight ambiguity and difference in the way people use UML concerning what it actually means if an object does receive a message in a state where the protocol state diagram says it shouldn't receive it. The idea is that it doesn't cause a state change when that happens. Well, in fact, this one isn't causing a state change anyway, but certainly it really shouldn't cause any kind of state change either now or in the future. What's going on here is eventually changing bulb age will modify the behavior of the object, so we really do need to reflect the fact that tick can only happen in the on state. Now, what about this one that we haven't looked at yet? It is a transition from the superstate to itself, and because of the history, that means that it's not going to modify the value of is on. We're going to go back to whichever of these states we were in before. But we're only going to take this new bulb transition if bulb age is greater than 100. Okay. And what have we got in the Java? We've got if bulb age is greater than 100, well, that's a good start, corresponds to our condition. Then is on equals false. System out print then replacing bulb, and bulb age equals 0. Okay, so now this is a protocol state diagram. It's not supposed to be telling us anything about the actual behavior internally of the object when it takes a transition, so it's fine that we don't have any correspondent in the diagram of this printing out and resetting of bulb age. But what's not so fine is that it actually changes the state. It sets is on to false, which means that when we take this transition we would always be going into the off state, whereas according to the UML diagram, if we were in the on state when this transition was taken, we should be in the on state afterwards. So I think what we should do is we should just comment that line out. And now, unless I've forgotten something, that's all we need to do. We've now fixed all the problems here. And we've got a total of 1, 2, 3, 4, 5 bugs. Quite a lot for 2 marks, but there you go. That's done.